Myself, A.M.Hari Priya, Assistant Professor in Aeronautical Department. Today discuss about your topic, Introduction to Avionics Systems. First topic, Introductions. Avionics systems are an electronic system used in aircraft, spacecraft and unmanned aerial vehicle. The terms of avionics is derived from aviations and electronics. This system play a virtual role in ensuring a safe flight operations and accurate navigation and effective communication and automatic control of aircraft. Next heading, the classification of avionics system. The avionics system are broadly classified into the following categories. First one, communication system. Second one, navigation system. Third one, control system, display system, surveillance and safety system, and aircraft management system. First one, communication system. The communication system enable the information exchange between the aircraft and ground station or other aircraft. They include a VHF and UHF radio communications, HF communication for long range, and satellite communications, telecom system for crew and emergency locator. Next heading, navigation system. Navigation system determine the aircraft communications, speed and directions. The common navigation systems are global positioning system, inertial navigation system, and VOR or VHF omnidirectional range, and distance measuring equipments and measurement landing systems. Next heading, the flight control system. Flight control system assisted the pilot in controlling the aircraft and maintaining a stability. It consists of fly-by-wire systems, autopilot system, and flight detector system, and stability accommodation system. Next heading, aircraft display systems. The display systems presents flight and system information to the pilot is an easily understandable form. They include analog cockpit instruments, glass cockpit, and primary flight display, multifunctional display, head-up display. Next heading, surveillance and safety system. This system improves situational awareness and flight safety. Examples are radar system, traffic collisions avoidance system, automatic dependent surveillance broadcast system, and ground warning systems. Next heading, aircraft management system. Aircraft management system integrated and monitor the aircraft operations. They include a flight management system, engine indicating and crew or alerting system, and central maintenance computers. Next heading, the flight safety and navigation system. The flight safety refers to prevention of accident and incident during a flight operations. The avionics system improves the flight safety by continuous monitoring aircraft performance and the surrounding environment. Next heading, navigation system. Navigation refers to the process of determining the control of position, direction, and speed of the aircraft during flight conditions. The modern avionics provide accurate and continuous navigation data. Next heading, communication with ground station. Communication with ground station is essential function for avionics system. It enables to exchange of information between an aircraft and air traffic control or ground personnel to ensure a safe and coordinated and efficient flight operations. Next heading, purpose of ground communication. Air traffic control and separation of aircraft, transmission of flight instructions and clearance, the weather and navigation updates, emergency reporting, and operation coordination during a takeoff, cruise and landing. Next heading, the communication system used. The avionics system used for communication with ground station, or it operates the frequency range of 180 to 137 megahertz. It is used for short range long of sight communication with air traffic control. Second one, HF communication system. It is used for long range communication, especially over the ocean. Operates the iconic isospheric reflection. Next heading, satellite communication. It provides a global coverage used for voice, data and aircraft tracking. And second one, data link communications. ACARS and CPDLC transmit the digital message, and it reduces the voice communication and pilot workload. Next heading, role in flight safety. It prevents mid-air collisions through air traffic control coordinations. It ensures timing, weather and traffic informations. It enables to quick response during an emergency. It supports control and organize the aerospace operations. And the communication system. It is a communication enables to exchange the voice and data between the aircraft and ground stations and other flights. These systems are essential for air traffic control, flight coordination, safety and emergency operations. Next heading, function of communication system. First one, the function with air traffic control. It exchanges the flight clearance and instructions. And third one, transmission of weather and navigation information. The coordination between the crew numbers, and it is the emergency communications. Types of aircraft communication system. First one, VHF communication system. It frequency range 118 to 135 megahertz. It used for a short range long line of sight communications, most common used for air traffic communications. Next one, HF communication system. It is used for long range communication. It is suitable for oceanic and remote areas. It operates using ionospheric reflections. Next one, UHF communication. It is mainly used in military aircraft. It provides a clear and secure communications. Next heading, satellite communication. It provides a global communication coverage. It is used for voice, data and aircraft tracking. Next heading, data link communications. ACARS, the aircraft communication addressing and reporting systems, and CPDLC, the control pilot data link communication. It is reduce a voice pollutions and pilot workload. Next heading, global positioning system. The global positioning system is a satellite-based navigation system that provides the accurate position, velocity and time information to aircraft anywhere in the world. And the main principle of GPS. The GPS determines the position by measuring the time delay of signals received from multiple satellites. Advantage: high accuracy, worldwide coverage, continuous position update. Next heading, inertial navigation system. Inertial navigation system determines the aircraft position, velocity and attitude with external signals. Principle: INS use the accelerometer and gyroscopic to measure the acceleration and rotations and computer position by integrations. Advantages: independent of external aids, work in all weather conditions, high reliability. Next heading, VOR or VHF omnidirectional ranges. It is a ground-based radio navigation system that provides a bearing information to aircraft. Principle: the system transmitting reference and variable signals, and the phase between them gives the aircraft bearing from the station. Uses and enshrouded navigations and airway guidance. Next, distance measuring equipments. It provides a sand range distance between the aircraft and ground station. Principle: the aircraft sends integrations pulse and aircraft ground stations replace. The distance is calculated from the air time delay. Features: accurate distance measurement, often paired with a VOR or ILS. Next heading: instrument landing system. Instrument landing system is a precise approach system that guides a aircraft during a landing, especially in a poor visibility. Components: lateral guidance, vertical guidance, marker beacon or DME. Importance: enable the safe landing, reducing landing accidents. Next heading: flight control system. First one, fly-by-wire system. Fly-by-wire system is an advanced flight control system in which the pilot control inputs are transmitted electrically rather than mechanically. The working principle: the pilot control movement are converted into electrical signals processed by flight control computers and sent to a actuator that move the control surface. Advantage: reducing the aircraft weight, improved flight safety, high precision and reliability, enables the flight envelope productions. Next heading: autopilot system. Autopilot system automatically controls the aircraft altitude, heading and speed without continuous pilot input. Function: it is maintain a altitude and heading, control climb, descent and cruise, reducing a pilot workload. Importance: the autopilot improves comfort, fuel efficiency and safety during a long flight. Next heading: flight director. The flight director is a guidance system that provides a visual command to the pilot for proper aircraft control. Function: it is a display pitch up and pitch motion and roll motion command on the cockpit display, guiding the pilot to follow the desired flight path. Benefit: improving the accuracy of manual flying, assisted during a takeoff, landing and climbing. Next heading: stability accommodation system. Stability accommodation system improve aircraft stability by automatically correcting unwanted motions. Working principle: the sensor detects aircraft motions and corrective signals are sent to control surface to damp oscillations. Advantages: enhance the aircraft stability, improve handling qualities, reducing pilot workload. Next heading: aircraft display system. Analog cockpit. Analog cockpit use a traditional electromechanical instrument to display a flight information. Features: individual round dialed instrument, mechanical and electromechanical indicator, separate instrument for speed, attitude and altitude. Limitation: higher pilot workload, limited information integrations. Next heading: class cockpit. A class cockpit replace the analog instrument with electric digital display. Features: LCD and LED screens, integrated flight information, reduced cockpit clutter. Advantage: it is improve situational awareness, lower pilot workload, easier information management. Next heading: primary flight display. It is the main display. It presents the essential flight parameters. The next heading: information display, attitude, airspeed indicators and attitude, headings and vertical speed. Important: centralized critical flight data, improve flight decisions making. Next heading: multifunction display. It is a secondary flight and flight and system informations. Information displayed, the navigation maps, weather radars, engine parameters, fuel states. Advantages, flexible, enhancing flight monitoring. Next heading, head-up display. Head-up display, it is a flight information directly into a flight pilot forward field of view. Features, a transparent car display, critical data overlaid on a outside view. Benefits, no need of to look down, improve your situational awareness and useful during a landing and low visibility. Next heading, aircraft management. Aircraft management, the flight management system and engine indicating and crew alerting system and central maintenance computers. Next heading, flight management system is an integrated avionics system used to plan, manage and optimizing aircraft flight. The functions, the flight planning and route management, navigation guidance, performance and fuel management, interface with autopilot and navigation system. Advantage, reduce the pilot workload, improve fuel efficiency, enhancing navigation accuracy. Next heading, engine indicating and crew alerting systems. In the engines, monitoring engines and aircraft system parameters and provides real-time information to the flight crew. The functions, it is a display engine performance data, it generates alerts and warning, priorities the crew actions during a failures. Benefits are improving situational awareness, reducing cockpit clutter and enhancing flight safety. Next heading, central maintenance system. Central maintenance system monitoring aircraft system and records faults from maintenance purpose. Function, the fault detections and isolations, maintenance data storage and system health monitoring. Advantage, it is reduce maintenance time, improving aircraft availability, support and maintenance. Next heading, avionics in modern aircraft. Integrated modular avionics and digital data bus and high reliability and redundancy. Integrated modular avionics is a modular avionics architecture in which multiple avionics functions share a common computing resource instead of using a separate detected hardware. Features, centralized processing models, software-based functional partition and shared input and output resource. Advantage, it is reduce weight and wiring, easier upgrades and maintenance, improve resource and utilizations, enhanced reliability. Next, digital data bus. Digital data bus is providing a standardized communication between avionics system. First one, ARINC 429, widely used in commercial aircraft, one-way data transmission. It uses twisted pair wiring, moderated data rate and high reliability. Second one, military standard 1553, they mainly used in military aircraft. Bidirectional and command response system, operates with a bus controller and remote terminals. Highly robust and fault tolerant. Importance, it enables to reliable data exchange, reducing a wire complexity and supporting system integrations. Next heading, high reliability and redundancy. Reliability is avionics prefer to ability of system to operate correctly under all conditions while ensuring a continuous operation in cases of failure. Types of redundancy, hardware, software, power supply. Benefit, fault tolerance, increased safety, communication with aviation standard, aviation safety standard. Next one, application of avionics, commercial aviation. The avionics systems are widely used in commercial aircraft to ensure a safe and efficient passenger transport. Applications are navigation using a GPS, INS, POR and ILS, and communication with air traffic control, flight management and fuel automation, and automatic flight control and landing. Next heading, military aviation. In military aviation systems support air missions, effectiveness and compact operations. Applications are radar and surveillance system, secure communications, weapon guidance on targeting and electronic warfare system. Next heading, spacecraft and satellites. Avionics play a crucial role of spacecraft and satellite operations. Applications include guidance, navigations and control, and telemetry and communications, attitude determinations and control, and space missions management. Next, unmanned aerial vehicle. The avionics enable to autonomous and remotely pilot operation in UAV. Applications are autonomous navigations and control, real-time data transmission, surveillance and resonance, civil and military drone operations. Helicopters. Avionics system improving helicopter performance and safety. Application include an awareness system and stabilization and autopilot system, communication and navigation in low altitude flight. General navigations. The avionics enhances safety and ease of operation in small aircraft. Applications are glass cockpit display, GPS based navigations, collision avoidance system. Conclusion. Avionics system form the backbone of a modern aircraft operation. They are integrated communication, navigation, flight control, display, surveillance and aircraft management function to ensure a safe, efficient and reliable flight. Advantage. Advanced aviations such as a fly-by-wire, glass cockpit, flight management system, integrated modular avionics have significantly reduced a pilot workload while improving accuracy and situational awareness. With a continuous advancement in digital technology, automations and artificial intelligence, avionics systems are playing on an increasing virtual role in enhancing a flight safety, operational and efficiency of future development of aviations. Thank you.